instead of telling students, we choose to show them through our software. So this is our home site, and if I scroll down, there's an introductory video that talks about why we exist. There are two videos that are getting a little bit outdated now, but when the government started talking about curriculum redesign back in, when trying to think, that was probably 2010, 11, 12, something like that. We came up with some videos that showed how not only are we aligned with the current Alberta program of studies, but we would have fit perfectly with all of the competencies. Back then they were calling them cross-curricular competencies for the new curriculum. And I've been on some of the kind of review committees for the new curriculum over the past few years, and I can say that we will align perfectly with those ones too. So we do have a grade 1 lesson plan, grade 4, grade 7, grade 9, bio 20, science 20, but these are not the only curriculum connections. Anywhere where you're talking about water, wildlife, the land, trees, plants, animals, you can use Alberta Tomorrow, and you'll see why soon. And if I scroll down a little bit more, there's a link to our board of directors. And then I just want to recognize our sponsors. So Alberta Tomorrow is completely free right now. We hope to keep it that way for Alberta anyway. We have plans to expand across the country, and that might be a different kind of funding model. But for Alberta, these funders have helped us to keep it free for the last almost, well, I don't know how long. It's been in existence since 2005. And the board of directors, and I would like to keep it that way. So about 2.5 weeks ago, almost 3 weeks ago, we launched our brand new version. So that's what I would like to show you today. So when you get to the home page, you're going to launch the new simulator. Now, I'm not going to go through the sign up process, just because it should be pretty straightforward. But when you go to the new site, it will ask you to create a sign up. It will send you a verification email to the email that you've registered with. And it will ask you if you want to register as a teacher or a student or a member of the general public. And I would suggest that all of you register as a teacher, because that gives you access to all the lesson plans. So when you get all registered, then you'll have your little profile area that talks a little bit about you. And then your dashboard that kind of talks about some of the steps that you would take to use Alberta Tomorrow, and I will go through these steps. Then there's an area called Teacher Resources, and this is where the lesson plans are available for you and any videos that are used in the lesson plans. So I'm just going to scroll down to the bottom here. If you've used Alberta Tomorrow before, these are pretty much the same lesson plans as existed before. They've just been updated to the new simulator. But there's a specific lesson plan for Bio 20 that looks at biogeochemical cycles, and then how does our land use affect those biogeochemical cycles. There is one specifically for grade 9 social studies that talks about government decision making and how do we balance the needs of the different stakeholder groups when what we need is a plan for Alberta's future that's best for everybody. That can be adapted for other grades. The beauty about this lesson plan is that it's kind of the stakeholder debate format. So the class is divided into a number of different groups, each representing a different stakeholder group. And first, they go in and they use the simulator kind of from the perspective of that group, so not their personal perspective. And then at the end, they have to make presentations, and groups can kind of critique the other stakeholder groups and say, you know, you guys didn't think about this factor, which is important to me. And in the end, kind of the class can be the government and decide what's best for everybody. There is one for grade 4, and if there are any grade 4 teachers out there, you know that the grade 4 curriculum focuses on Alberta, so perfect fit for grade 4. And I would say probably over 50% of our users are probably from that grade 4 class. Then there's one for grade 7. So that talks about interactions in ecosystems and kind of the intended and unintended consequences of our activities on the landscape. Once again, there are linkages for other grades there, even grade 9 science. We do have an optional land use field trip that if you want to take your class out to some water body somewhere, you can do water quality sampling, you can upload your data to Alberta Tomorrow, but this file will kind of have all the instructions that you would need to go out with your class or your students. You would need to have your own water sampling kits, which are fairly readily available. Here's that stakeholder debate that I kind of pulled from the Science 9 lesson plan. Now, some of these lesson plans that are up higher are the brand new ones. And these 3 right here are kind of the general lesson plans. And so you can see that they go from grades 4 to grade 11, basically because they're going to walk you through using the simulator and walk your students through using them. So it doesn't really matter what grade you are. The questions are not specific to a specific grade curriculum, but it'll just kind of walk you through. So this one is looking at the past, looking at today and tomorrow. Then this next lesson plan is where the students actually make their own land use plan for the future. So you would do this after they have understood how the landscape has changed in the past. And then finally, this one is now that you understand kind of what's happening on the landscape, then for the future, we have to start thinking about climate change. And are you going to simulate the future with a mild, medium, or hot climate change scenario? And I'll show you some of that. Then these first 5 lesson plans are kind of a new project for us. We're working with an organization called Guardians of the Ice, and they're concerned with protecting the Columbia ice field in light of climate change. So we know that we are losing ice on the ice field, and these lesson plans are all looking at glaciers, linking them once again to the Alberta Program of Studies, looking at chemicals we find in the ice, how did they get there, talking about persistent chemicals for, say, grade 9 science, a little bit of chemistry, talking about isotopes for, say, grade 10 science, and how is climate change affecting the glaciers. These have links to many videos about glaciologists talking about what's happening on the glaciers, and also a guy by the name of Peter Lemieux, who has been working on the Athabasca Glacier for the last probably 25 years. So little video clips of him. So these are all searchable. You can add filters, and if you're only looking for grade 7 materials, those ones will come up. If you're only looking for science and not the social studies, those will come up, and so on. So the next tab over here is your mission. And once again, it kind of walks you through what you should do. So first of all, you're going to set up your profile. You're going to watch the videos, which are coming up in a tab. You're going to explore the map and look at the different land uses or evidence that we can see that land use is taking place. We are going to create a scenario, first looking at the past, then looking at what the future might be if we keep on doing things the way we have been. And then finally, you're going to create your own plan for Alberta's future, and then look at the climate change piece and how is that going to affect your future plan. So the next tab below then is the Explore tab. This is where you can look at the satellite imagery, and you can look for signs of evidence that humans have changed the landscape. So I'm going to go up here to this purple tab, and I'm going to change it to the satellite view from the street view. And there could be a bit of a delay here, so I'll try and go kind of slowly. And also, I'm not sure what your screen resolution is, but let's just say we look down here somewhere between, let's say, Calgary and Lethbridge. So kind of your school division area. And when we start looking at this, well, wow, we can see that humans have actually altered this landscape quite a bit. And we can see agricultural fields and all these weird rectangles and squares. And then over here, we can see these perfect circles. And many people do not realize that these perfect circles are all from irrigation pivots. And it gives us a sense of looking, when we look at the satellite imagery, to see exactly how much land we are actually irrigating in southern Alberta. If we wanted, we could also look into the forested areas. And when we look into forested areas, we start to see clear cuts that have taken place in the forest. I'm just going to go up here towards Cochrane, because that's what I'm kind of most familiar with looking at, and up into the Ghost. And when we zoom in over here, we start to see all of these little blotchy areas, which are all clear cuts from the forestry industry. So looking at the satellite imagery and just exploring around the whole province, going up to the Canadian Shield, seeing how the landscape looks different, looking at northern Alberta and seeing how much wetland there is, will help students kind of gain an appreciation for the differences that we can see throughout our province in terms of landscape. The next tab here has all of our videos. These videos are short. They're probably 30 seconds to about 5 or 6 minutes would be the longest one. And I'm not going to show you the videos today because you can spend time and review them at your leisure. The lesson plans actually have your students go through all these videos, and there are questions for them to answer as they work through them. So you can kind of ensure that they do in fact watch the videos, because there's some really important information in here that helps them to understand what they're seeing when we actually start doing the simulations on Alberta Tomorrow. You can see that we have some general ones talking about ecological goods and services, management practices, one on climate change. Then we have ones that match our environmental indicators. So talking about the natural landscapes, this goes through all the natural ecoregions in Alberta. We've got one on caribou habitat, because that's our indicator species for the northern half of the province. We've got one on grizzly habitat, because that's our indicator species for the southern half. One on fish habitat, one on water quality that talks, it goes a little bit more in detail about the phosphorus cycle and the nitrogen cycle. So there's some linkages for older grades, but certainly younger grades can watch these and understand what happens when we add too much, say, phosphorus fertilizer to the land. They just don't necessarily need to know all the details like you would in high school. And then there's one on greenhouse gases talking about the natural greenhouse effect, and then what happens when we add too many greenhouse gases to the atmosphere. Then we have ones on our social economic indicators, really short. How has our population grown? What is GDP? So gross domestic product, just a measure of the economic activity, basically. And I'll have grade 4s talking about GDP and debating with somebody else about what needs to change on the landscape, taking into consideration GDP. So younger students can totally get this information. Oil and gas industry, forestry, and agriculture. Those 3 videos talk a lot about the economic benefits that we get from those land uses, and then also some of the environmental liabilities that come with those land uses. So it's balanced. We're talking about the benefits and the drawbacks, talking about how they contribute to GDP, why Alberta has a higher GDP compared to some other provinces in the oil and gas industry video. Then we have the last one on water consumption that talks about how much water we're actually using in the province. So I'm going to stop it right there. Make sure I'm still connected with everybody. I need like a thumbs up or a yes, we're all good. And then I'll keep going.
I'm hearing you well on my point. So
okay.
If there's any questions, please bring them along, people.
Yeah. And if you can, well, I don't know. If I'm continuing to talk and you can't see something, let me know. Because, I could be talking for half an hour and nobody's actually there. All right, so that's kind of an overview. This is a new section that we have, and these are a lot of those videos that are new to the simulator in terms of system observations. And these are the ones that are linked to the lesson plans, specifically the glacier lesson plans. So here's Peter talking about the Athabasca Glacier. Here's a video from the Coldwater Institute based out of Canmore. They're actually the University of Saskatchewan, but they're based out of Canmore, showing the Peyto Glacier actually calving in kind of a time-lapse photography. How much of the glaciers are we losing? This one links to the lesson plan that has students calculating if we're losing this much ice during the summer and gaining this much back in the winter, then after 5 or 10 years, how much ice have we actually lost? Here's a little trailer for the Guardians of the Ice documentary that they're planning to make. But lots of short little video snippets. We will be adding more of these. For example, this one right here is an Alberta fisheries biologist called Mike Sullivan. He's an excellent storyteller. And here is actually a video clip from the Edmonton Journal, I believe, where he's talking about massive fish kills in a lake just east of Edmonton and kind of explaining why that's happening, and it's probably due to excess nutrient input into the lakes. So then that links back to some of the lesson plans. So I'll skip the scenarios and go down here to the observations section. This is where if you are out with your students or you instruct your students to go out and take some water quality observations or land use observations, you can upload it and save it here within the simulator. So for example, sometimes I work with students here in Cochrane, and we go out and we do water sampling in our local kind of creek. Oh, look at that. Okay, over here. And you can zoom right in to where you are actually doing your water sampling, and your information then is geotagged to that specific location. So for example, this data was taken from Cochrane High School students doing water quality sampling. I uploaded it in 2020, but I think it's from about 2014 actually. They did their water quality testing. I've uploaded a picture, all their data is there. And if you explore the screen, you then, as we get more data points put in, because we have many in the old version, but we might not be transferring all of them, you guys could be in your local water body, say somewhere in here. You can do your water quality testing, you can upload your data, and then you can compare it to what the Cochrane High students got at Big Hill Creek in Cochrane. And did you find the same amount of nitrates and phosphates? Did you find more? Did you find less? Why might the water quality be different? What if we went out here to Canmore, closer to the headwaters, or to Ray Glacier over here, closer to the headwaters of the Elbow River? Would the water quality be the same? Why or why not? And have those discussions about how land use actually affects the water. So I am now going to go to the scenarios section, because that was just a general overview of the site. And I'm going to show you how the system actually works. So you will create a new scenario, and we're going to start by looking at a historic scenario. And we're going to look at the historic, not cow, Bow watershed. And we're going to create this scenario. We have to choose the Bow watershed. So we are all part of this Nelson River drainage area, but I am over here in the Bow River watershed. And you can see that we can actually narrow down to sub-watersheds. I'm not going to do that today, just because sub-watersheds means we're going to see a little bit less change over time, and I want to show you a greater amount of change. But if you are concerned with just looking at a sub-watershed, you certainly have the ability to do that. So I have chosen the Bow watershed, and now I'm going to run my scenario. So this is where the simulator is doing all the calculations, figuring out how the landscape changed in the past and how that has affected environmental and social economic indicators. So before I press play, I'm going to explain what it is we're seeing here. So this map overlay right here is showing what the landscape was like in 1910. So in 1910, we had a whole lot of yellow. And if we go down here, yellow represents grassland. Orange represents agriculture, and you can see there's none yet. The blue represents water. The light green is wetland area. The dark green is forested areas. The purple are cities and towns. Gray represents industry and transportation, so things like the oil sands or airports, large areas that are just industrial will show up like that. And then the white represents alpine areas, exposed rock, glaciers, that kind of thing. So those are the landscape types and the actual colors. But if we look up here to the dials, these dials, we have 6 environmental dials. The first one is the area of natural landscapes. We've got grizzly habitat because we're in the southern half of the province, fish habitat, phosphorus runoff, looking at water quality. So that's the indicator we use. Biotic carbon storage, so the amount of carbon in living things, the trees, the grasses, the soil, the little plants, and then man-made CO2. So in the year 1910, our environment was pretty good, pretty pristine. Now, our social economic performance hasn't really started yet. It's showing 0 people. That does not mean there were 0 people because Calgary existed already. We had Indigenous people here. But those people were not using the land the way we use the land today. So as such, they're kind of not showing up. Their impact is not showing up. Now, our GDP is at 0 because we hadn't yet started hydrocarbon production. Forestry industry hadn't begun yet. Agriculture hadn't started yet. And the number of swimming pools, so water consumption, well, we didn't even have running water. So we certainly weren't using very much water. So I'm going to go down here and I'm going to press play. And when I do so, we're going to go 110 years from 1910 to the year 2020. See how the landscape changed. So our map overlay will change and these dials will change also. Now, when you do this on your own, it should be nice and smooth. On the streaming, it might be a little choppy. So in 110 years, this landscape changed quite a bit. And I'm guessing that if we looked at further south in the Lethbridge area, we would see a similar change in that we lost our native grassland. And we can see here that we lost 786 hectares of native grassland, and we gained 722 in agricultural land. We gained some watery areas, actually. We lost wetlands, and we lost forested areas, and we gained in the purple, which are cities and towns, which obviously Calgary is a big part of the study area. So these changes, you could ask, are they good changes or not so good changes? But really what we have to look at is these indicators. So I think natural landscape started at 100%. Now we're down to 46%. So the question then is, what is the impact of that? Or how does this dial, how does it relate to some of the other dials? Well, for example, we know that native grasslands absorb more carbon. So they would have more biotic carbon. Well, biotic carbon also fell, probably largely due to the fact that we lost those native grasslands. And for each one of these dials, there's kind of an information button saying what we're actually measuring, a link back to the video if you didn't watch it or you forgot what some of the important points were. So if we continue going on, well, we lost grizzly habitat. Grizzlies don't like people. They don't like tractors. They don't like the agriculture. So in this area, there's actually not much suitable grizzly habitat left, even though there are a few grizzlies over here in the Bow Valley, but we know the problems that they have there. Fish community health or fish habitat went down. Water quality went down. Okay, well, why did water quality go down? Largely due to the two greatest indicators that affect water quality would be the size of agricultural land, and we gained a lot of that, and the size of purple, or cities and towns, and we also gained a lot of that. So there we go, that has affected our water quality. Biotic carbon storage went down, and greenhouse gases started to go up when we started using oil and gas to drive our cars and to heat our homes. Most students see this and they kind of are not super excited about it. And then I say, okay, but what was the trade-off here? The trade-off is for people to live here and for us to have money and people to have jobs. And we now had oil and gas production and forestry and agriculture, and we were producing food. And yes, we were using some water, but to get all of this, it did impact our environmental indicators. So this is kind of a canned simulation. There's nothing that the students are actually doing to change anything, but they can start to make those connections between the different dials and how changing the landscape will affect those dials and how one dial can affect another dial. So that's a historical simulation. I'm just going to pause and go back here and see if anybody has any questions. And I'm going to turn my camera off.
Jennifer, there was one question that came up earlier. So far, this is brilliant. I'm enjoying this. I like that there's no real prejudice or bias in the presentation of the data, and so it's just leading to discussions there. But the question that came up earlier was about: is there a intent on your guys' part to create some or a future plan to create some grade 1 to 3 content?
I guess I would ask the grade 1 to 3 teacher about that. I'm trying to think. So grade 2, I think, has a big wildlife section. Grade 1's more about communities, I think. So I hadn't personally had any plans because I didn't see as great a curriculum connection there. Having said that, I would look into it if someone has some really good ideas of what we could do. And then on the other hand, I would say that, you know, this is available to you to use however you think, you know, even without a lesson plan, you are welcome to use it wherever you think it would be appropriate. Not sure if that answers the question.
Shabana, feel free to chime in if you want some more information, but thanks, Jennifer. Yeah.
Okay, so that was one of 3 scenarios, well, probably 4 scenarios we can make. So I'm going to go here and I'm going to add a scenario, and I'm again going to create a new scenario. And this time I'm going to do a business as usual scenario, and once again for the bow. And business as usual is assuming that we are doing everything the same as we have in the past. So the last 30 years changed, let's just continue that in the next 30. So I'm going to once again choose the Nelson River drainage and then the Bow watershed. And I should also mention that one of the new lesson plans has students look at the watersheds and try and figure out, well, 1, what is a watershed? And 2, what watershed do they live within? And where does their water initially come from? So if you think, well, who cares if the Athabasca Glacier is contaminated and persistent chemicals are being melted out of it due to climate change? Well, we should care here in Calgary because that's where our drinking water comes from. So there's a lesson plan on that also. So I'm going to run the scenario. Remember, this is business as usual, looking at 2020 to 2050. So we can see where we're currently at, and I'm going to press play down here and see what might happen in the next 30 years in this business as usual scenario. So what do we see? Watch it one more time. So it looks like the social economic indicators keep going up. The greenhouse gases keep going up, and some of the other indicators, environmental indicators, keep falling. And the number of swimming pools or the water that we're using goes up also. So then the question will become, is this what we want for the next 30 years? Or can we change that future in some way? So if I go back to scenario, and now I'm going to create a new scenario, and this time I'm going to do a land use scenario. So I'm going to create a future plan for 2050 for the Bow River watershed. And right now you have to put in a description, and so you can't see my bad typing. I'll just go like that, and I'm going to create the plan. Now this step has a bunch of, this scenario has a bunch of different steps. So first, yeah, we have to choose our watershed, and I'm going to stick with the Bow. Then the next thing that we have to do is we have to decide what our goal is for each one of these indicators for the future. So if right now we are at 45.87% natural landscapes, in the future, do I want that to be more? Do I want it to be less? Do I want it to stay the same? Well, I personally would like to see that go up, because I kind of know that if I have more natural landscapes, there could be more suitable grizzly habitat. That's likely going to help my fish habitat. That's going to help my water quality and my biotic carbon storage. And natural landscapes absorb more CO2, so my CO2 emissions should go down. Now, the trade-off, which students won't initially get, but they will after going back and forth, is that if I raise the area of natural landscapes, that means that something's got to go down over here. So if I'm taking agricultural land and changing it back into natural landscapes, or if I'm this is impossible, but taking Calgary and turning it back into a natural landscape, then these are going to go down. So what is realistic to set as a goal? Some grade 4s may choose to increase it to 100%, but we know that that's not possible. But I do want to get a few more. Okay, so I'm going to set these. I want to see if we can get some grizzly habitat. I want to make fish health better. I want water quality to get better. I certainly don't want it to go down. I want to increase biotic carbon storage and decrease greenhouse gases. But I recognize people are going to continue wanting to live here. I don't want to double our population, but can we get more people living here? And maybe I can change how it is we're living in our best practices. GDP, well, nobody likes to see less money, so can I increase it a little bit? I know that GDP comes from barrels of oil. I know that it comes from the number of logging trucks in the forestry industry and number of people fed in agriculture. And I want water consumption to go down, because here in Southern Alberta, we're pretty concerned with the amount of water we have. Northern Alberta, not as much, but so we don't want to be wasting water. So I've set my goals, I would say like a pretty average Albertan. And I say that in kind of jokingly, in that I want everything. I want my environment to get better, but I also want GDP to go up, and I want to have more industry, and I want to be able to do everything that we have been doing. Okay, we'll just leave the goals there. We can always come back and change them. And then the next section, you move on to changes. Now, in this section, this is where you decide where you want the landscape to change in order to reach those goals. So for example, I want to increase natural areas. So I'm going to click on grassland, and I'm going to say, you know, over here by Airdrie, I want that to increase or change to grassland in the next 30 years. I can adjust this and say I want to have 51 hectares. It defaults to, I think, 26 hectares. Maybe I want to protect us against flooding. So I'm going to put some wetlands up here in the upper reaches of the watershed. I'm going to change this back to forested areas. Oops. And I am recognizing that Calgary is going to grow, and I had set my goal that I wanted Calgary to grow. So I'm going to grow it over here and down here. So you can see right here the changes that I've made. And when you look at the landscape composition, you can see where it was and where I want it to be in the future. Now I can go and look at my management. These are those beneficial management practices, that things that we can do or industry can do to lessen the impact on the environment. I'm going to leave those for now because we'll come back to them. And I'm also going to leave climate change for right now. We're in the no scenario. And I'm going to run my scenario. Now this time, the simulator is going to show me if I can reach my goals based on the changes that I made on the landscape. So let's see how well I did. Here we are in 2020, and I'm going to press play and simulate 30 years into the future. I can see some grassland has grown around Airdrie, and Calgary got bigger. And here's a little challenge for me that pops up every once in a while. Forestry company and an oil company are cooperating in building a road to get to the same area. In the industry, this is considered a best practice. Which of the following is also a best practice? So cultivating land adjacent to wetlands? I don't think so. Reducing the width of seismic lines? Yeah, that might be. Increasing the size of well pads? I don't think so. So let's see if this is the right answer. And I gained some points for doing that. I gotta use this more. I want to be the high scorer. Okay, let's continue. So back to my plan. And those things will pop up just intermittently. Sometimes they're feedback based on your plan. Sometimes they're just random things that will come up. So if I look up at my environmental indicators, I've got reds, I've got oranges. Red means I didn't reach my goal. Orange, I got kind of close. Green means I reached my goal. So the only goal that I actually reached in this landscape plan was the number of people. And I had added, what did I add here? Oops. I had added 52,000 hectares of urban, and I was able to reach my goal. Okay, well, since I didn't reach my other ones, what do I want to do? Do I want to say, maybe it's not realistic to get 10% grizzly habitat. Can I try and get 1% grizzly and I can save my goal there? Maybe I need to make more change on the landscape to reach my natural landscape goal, for example. So then I could go over here and I could add some more grasslands and see if that will allow me to reach my goal. So what happens is students start to get the idea of how much change has to take place on the landscape to reach those goals. They also start to get the idea of what goals are actually realistic. And it becomes an exercise of kind of going back and forth. Now, before I simulate, I just want to explain how this growth works. So I could try and put grassland on the top of a mountain, but the simulator knows that it's not possible to change exposed rock into either any of those landscape types, actually. So the simulator will try and say, oh, that's not possible, and it won't happen. There are certain probabilities. So can I change the grassland back into native grasses? Well, I actually can. It's not going to be the same as a native grassland, but it is actually going to, I can plant native seed and I can try and restore that grassland. Is it as easy to change an urban area into a grassland as agriculture into a grassland? So each of these landscape types have probabilities of whether they can change to another landscape type or not. So let's just go back and simulate. Oh, no, I want to run my scenario. And see if adding all that grassland maybe will allow me to reach my goals for native grassland, or sorry, natural landscapes. And I press play. And you can see that natural landscapes went up, but at the same time, I was taking natural landscapes away from urban areas. So agriculture, the amount of land devoted to agriculture is falling. What does this mean for people living in the area? So something to think about. Well, if agriculture is falling, then there are fewer people making as much money off that land. That means there's less food being produced in our local area, and we might have to import food. So lots of implications of losing agricultural land. We know agricultural land's not great for water quality, but on the other hand, we still need to eat. So all of these things we have to take into consideration, and there are no easy answers. The last two things I will show you is the management practices. So I can do two things here. I can actually change the level of industrial activity just by moving this slider. And industrial activity is basically how much forestry and how much oil and gas is taking place on top of the landscape. So this defaults to 30 something in this particular study area. I could raise it to 100, but as I do that, then that affects my environmental indicators even more. Look at natural landscapes went down to 1%. Or I can move industrial activity to 0, but then GDP falls greatly. So the students have to make a decision where they want that to be. Then in terms of beneficial management practices, they get to choose which ones they want to use. So we have agricultural fertilizer best practices. So carefully calculating how much fertilizer will be put on the land. Agriculture water conservation, municipal water conservation, energy sector water conservation, which is mostly or more so in northern Alberta with the oil sands. How much renewable energy are we generating? Are we going to phase out coal? Are we increasing the use of electric vehicles? Are we increasing the density of our cities and towns so we have more people in a smaller area? Are we going to try and decrease our industrial footprint? So students can choose which ones of these they wish to use. And by doing so, that actually changes our final outcome. And so if we choose to use these, you can see what would happen to, oh, geez, did you see that one? So agricultural fertilizer practices, if we don't use them, our water quality is 28.87%. If we use best practices in fertilizer application, water quality goes up to 39.81%. So do we want to be using best practices? Certainly. And students can play around with which ones affect the indicators the most. So I would say that this is not a done plan. I would still want to go back because I don't have a whole lot of green. And once again, maybe that's because my goals were unrealistic, or maybe I didn't make enough change on the map, or maybe I'm not willing to accept these trade-offs because I can't increase natural landscapes and human population and agricultural area. So which one of these am I willing to kind of compromise on? The last section is the climate change section. And to do this one, I actually want to show you northern Alberta because we see the most change in northern Alberta. So I'm going to actually just switch to a business as usual for northern Alberta and choose my study area. And we're going to look at the whole Great Slave Lake drainage. And I'm going to run the scenario. Now this part gets a little bit more complex, but basically we are looking at different scenarios based on RCPs from, sorry, I'm forgetting the name of the international organization, IPCC. We know from organizations who've done work in Alberta, like the ABMI, Alberta Biomonitoring Institute, that climate change is going to affect our biomes, our ecoregions. And so, for example, when we look at this scenario, so this is all of northern Alberta, and if you remember the light green, I'll go back here, the light green is wetland areas. So I know when you look at the satellite imagery, that's all forest, and that's true, but it's actually black spruce forest, which black spruce grow in boggy areas. So it's not always merchantable forest. And you can see that we have a whole lot of wetland areas. There's some open water, and then we've got forested areas. This is assuming no climate change, and we can simulate 30 years into the future and see what happens to the areas. So down here, we do lose a little bit of wetland areas. We lose some forest, native grassland. But then if I go over here and I switch to the hot climate change scenario, and this part of the simulator is not quite finalized because we're trying to make a comparison tool so you could have two side by side. But now when we run the hot scenario, watch what happens to especially the amount of light green on the screen in the next 30 years. And I know it's kind of hard to see when you don't have them side by side, but if you notice, we're actually seeing a lot of this light green change to dark green and change to grassland. And so then we can have discussions of what are the implications of that on northern Alberta. And you can see that there's the caribou habitat because we're using caribou for the northern, and caribou actually gets impacted quite a lot in this hot climate change scenario. So as I said, we're still working on kind of a comparison tool. I like to use the example of if you're shopping for sleeping bags at Mech, you can bring up one sleeping bag and it's got all the specs. So how much does it weigh? How cold weather can you use it in, what it's filled with, and then you can compare that to another one. So you would have it kind of side by side. So that's the last part of the simulator. I would like to bring it back to questions or comments that you have, and how you see using this with your students in the future.
I'll key in here, Jennifer. We unfortunately there was some overlapping meetings here, so we lost a couple. So Kyla, if you have any questions, we're down to one. Our numbers were small, but thank you. I think that there's value. I think that everybody left seeing the value in it and stuff like that. Kyla, if you have questions, please just crack your mic open. This is your time to shine. But
I have any questions? A powerful tool. Yeah, I'm teaching right now, so I can see how subject-based that
I'm not sure if you're hearing this too, Jennifer, but Kyla, your mic is muting on and off, cutting in and out here. So if you want, oh, go ahead.
My eye at home is terrible.
Unfortunately, it's kind of coming in and out, and we are getting every third or fourth word. So you know what? Feel free to email me. I think, Jason, did you provide everybody with my email?
I will be. Yeah, absolutely.
Yeah. And feel free to email me or call me, and I would be totally open to discussing how it might work best in your class, depending on what grade you teach. But yeah, if that's going to work better for you to communicate, feel free to do that. And Jason, if you could make that available to anybody who was on, if they had to leave early. And also, I will probably send you some sort of an evaluation form if I could get some teachers to fill that out, just to help me make some of these webinars better.
Absolutely. So I don't know if you see that, but Kyla just chimed in and said, it's just a powerful tool. I can really see how I would be able to use this throughout the year. So
great. Yeah,
cool.
And it's not something that you use for 15 minutes and that's it. And often it can be used as an introductory tool. Then, you come back to it after I know grade 4s will come back to it after a month and then do some more work and then revisit it at the end of the year when they can put all of the information that they've learned together, and then using the tool is that much more richer when they have that much more knowledge behind them.
Yeah, and that's what I was going to say, is I could see this as a starting point where you start talking about, okay, what are all of these things that potentially impact, and then also as a ending point where you say, okay, now that we know all of this, let's develop that land use policy. So yeah. Kyla just chimed in here too. I really appreciated Oops, I lost it. I really appreciated the walkthrough. I signed up last week, but was unsure how to use it. Now I have a much more clear idea. So that's great.
Yeah.
So Jennifer, thank you for your time. I think I will share this recording. I've taken some notes here to highlight this, and I will share your information with our teachers as well. And if you do send over a evaluation form, I'll share that out with anybody who is in on the webinar here. So
great. And at the bottom of the evaluation form is kind of a plug for our webinar that we're having on May 27th at 11 a.m., where we're bringing together three Alberta scientists, one from the States, all talking about Alberta's water, glaciers, climate change, and how it affects us. And that will be open up to all teachers, all students who want to join that particular webinar. So it'll be very curriculum focused. You know, there will be opportunities for younger students and younger curriculum links, as well as some more in-depth things for junior high and high school.
Cool. Yeah. No, I was, you know what, I was sad to see when this COVID-19 went down that you guys had to cancel the one from the glacier there. That would have been cool. So
I
know. Yeah. Okay. If in that case, I'm going to stop the recording here. We'll say thank you to everybody. And yeah, I think